Well, every lecture will conclude with a summary slide. And in today's summary slide, we want to highlight two things that we learned in this very first lecture of the course. One is that different users' signals interfere with each other in the air. And that happens in all wireless communication. In the cellular world, we use transmit power control to manage this interference, to mitigate the impact of this negative externality. In particular, we saw the picture of a feasible SIR region, the trade-off, with a Pareto optimal boundary. And we saw the cocktail party analogy. In this case, we're controlling the volume of all those that talk during this cocktail party. We also saw a specific mathematical formula. It's called interference coordination with distributed power control, a DPC. And the conceptual highlight is that there is a negative feedback, and the feedback is all captured in the current SRR value. You just compare that with your target fixed gamma and use that ratio to adjust your power level up or down accordingly in the next time slot. And we saw that this can be viewed as a distributed solution to an optimization problem, which turns out to be a linear programming. Or we can model that as actions by intelligent agent in a non-cooperative game that models the competition due to interference. Both the conceptual points of interference, tragedy of common, negative externality, as well as the mathematical language, such as what defines optimization problem and what defines a game, will be so frequently used over and over again in the rest of this course. And indeed, in the next lecture, we will shift gear from the world of CDMA over to the world of online ad auction. How does Google sell the advertising slots on a search result page? We will see how the ideas we talked about in a game can be applied to analyze the mechanisms that Google uses. So see you at the next lecture.